Thunderfoot, take a ride with me. We're using Google Earth.
Ah yes, Google Earth, the perfect tool for the armchair scientist.
At an altitude of 7,886 feet. We're going to fly across an island in the Pacific Ocean at a speed of a few thousand miles per hour. That little model you've concocted in your head that you think demonstrates that the crust of the Earth couldn't exert enough force upon the water inside it to cause the water to eject with enough velocity to surpass the escape velocity of the Earth and therefore shoot into space is based upon ignorance. You see, Thunderfoot, as when the flood occurred, the ocean floors sank.
Correct me if I'm wrong, the island you are showing is Hokkaido, the most northerly Japanese island. It's a real mishmash of geological features from sedimentary, metamorphic rock to volcanoes and uplifted mountains. Either way, this island has risen rather than the oceanic floors sink. Indeed, in your model, why do only certain sections of the crust sink and become oceanic basins? More embarrassing and searching questions to follow.
We're not talking about a small amount of pressure upon water. We're talking about 6 miles of the Earth's crust forcing down upon water which encompassed the entire globe. That is why the ocean floors sank, because the water that was in the Earth, when it was expelled, the space it vacated caused the ocean floors to sink to fill that empty space. And the floodwaters eventually went into these now deeper oceans. Now,
6 miles? Where did you pluck that figure from? So, if the whole Earth had this underground reservoir, then why didn't the whole of the crust fall into the vacated space? Now, you don't have to be a rocket scientist to know that if the crust fell as one, it has less volume to fall into. We should then see a jumble of massive fractured chunks occupying all sorts of angles. Take a look at the ocean basins that are not immediately near the oceanic ridges. You will see the underlying rock being level and of a uniform consistency, usually of some form of basalt. Of course, you won't spot this by using Google Earth. And Neph, while we're at it, I would love to know why the continents are largely granite and the oceanic basins would be largely basalt. Granite and basalt, while both igneous, are of different character and known to form under completely different circumstances. So according to your model, in the pre-flood, why was it just the basalt rock that collapsed into the global reservoir of water? Don't you ever put any thought into what you say? No wonder people laugh at creationists.
Back to our little trip. As we leave this island and hit the edge of the continental plate, we come to a drop-off. Now we are at an altitude of almost 8,000 feet. How far down do you think that cliff is? How far did the ocean floor sink?
Ooh, I should say about 6 to 8 kilometers, Neffy boy. But what's your point? Again, is it the same material as that island whose identity you were reluctant to reveal? Besides, Neffy, I can't really see the cliff for the shadows, so you'd better move it and groove it.
How much water was in the Earth that is not now?
And how many fish were in the water that are not here now? Neffy, if your hunch is true, then it's only a matter of time before we find fish on the moon. This is the trouble with young Earth creationists. Each lie requires at least one more to cover it until you spiral into a pit of confusion.
Now remember, we're at 8,000 feet almost. That's one heck of a cliff. How much pressure do you think was upon the water, Thunderfoot? That's an amazing cliff, isn't it?
Amazing indeed, but you have not proved that it fell in one catastrophic movement. Just thought I'd mention that.
But let's not stop there, let's keep going. Now remember, we're at almost 8,000 feet altitude, moving at probably 4,000 to 6,000 miles per hour. The video you're watching is quadruple in speed.
The speed at which you operate Google Earth is totally irrelevant, but thanks for telling us anyway.
And we come to another sheer cliff, thousands of feet high. How far down and how much pressure was upon the water, Thunderfoot? Does your little model make any sense? I don't hardly think so.
But Neph, when are you going to put some calculations into the mix to justify this unsubstantiated claim? In your calculations, don't forget the resistance to the fall of this 6 miles of rock by the very water reservoir that you have concocted. Don't believe me? Then get out your armchair and throw a brick in some deep water and see if it attains the velocity that it would in air. Basic laws of motion, Neph. The water itself will cushion the falling rock.
But why stop now? Let's keep going. How much water was there, Thunderfoot? How much pressure was created by 6 miles of the Earth's crust all the way around the Earth pressing down upon this water?
No, Neph. Don't you think you should tell us how much pressure? I'm humouring you now. So assuming that we have enough force to expel the Earth's water, then how did the Ark survive that little lot? Go on, tell me. It was sheltering in Pearl Harbor.
So, Thunderfoot, your tiny little model that you concocted in your mind.
Concocted? The words kettle, black pot and calling spring to mind. Thunderfoot. You know, that's still just as hilarious as when you first said it. I.e., not at all.
Doesn't really fit, does it? Doesn't work.
Yours doesn't even begin to work.
Do you see? The pressure created by 6 miles of the Earth's crust bearing down upon water, which it was all around the Earth, causing the ocean floors to drop all around the Earth, was far more than enough force to cause the waters to eject with enough velocity to escape the Earth.
Look, Neph, like I said before, you need to consider the resistance of the water and provide us with some maths. Although impossible, even if water did escape, it's only the start of your problems. So, astronomers should be able to spot Earth water, Earth rock and fish in all directions in space. And not to mention fragments of the Ark and perhaps a zebra or two. Still, at least it explains where all the unicorns went, eh, Neph? What a turnip!